Alright, comparison of light wave and with the sound wave. The two main differences between sound wave and light wave. The first difference is velocity. The sound wave they travel with the air at a speed of approximately 1,100 feet per second. The light wave they travel through the air at an empty speed of approximately 186,000 miles per second. The second, the difference for the sonic wave with the longitudinal wave, the alternate compression and expansion of the matter that is composed of the transverse wave electromagnetic field. Although both of the forms of the wave motion off some require solid, liquid, or gaseous medium, whether the light travel the empty space, the denser for the medium of the greater speed of the sound, the opposite of the true of the light travels approximately 1/3 slower than water, and then in air, sound travels through substances, but light cannot pass through oblique materials. For frequency effect for the both sound and light, certain ranges of sound frequencies produce sensation that you can hear. The slow vibration, low frequency sound gives the sensation lower note. More rapid sound vibration, the higher frequency produced for the higher note. Likewise, the center range for the light frequency produces the sensation you can see with the very violet light is produced for the high frequency end of the light spectrum. The red light is produced for the low frequency end of the light spectrum. Change in frequency sound waves cause an audible sensation difference in pitch. The change of the frequency light waves cause the visual sensation difference in the color. For comparison, light wave, sound wave, listen to table 1, 2, electromagnetic spectrum. Light is one of kind of electromagnetic energy. There are many other types of inducing, including heat energy, the radio energy. The only difference between the various types of electromagnetic energy, the frequency of their wave, the rate of the vibration. In terms of the spectrum, you have the design. The entire range of the electromagnetic wave, the range of the in order, the frequency of the visual spectrum contains only the wave that simulate with the sense of the wave. Sense of the sight, the technician may be expected to maintain equipment of the electromagnetic wave within and above the below the visual spectrum. There are neither sharp divine line with nor gap. The electromagnetic spectrum figured 121 illustrates how a portion of the electromagnetic spectrum overlap. Note that only the small portion of the electromagnetic spectrum has visual wave lights in which can be seen in the human eye. Electromagnetic wave. In general, same principle, the property of the light wave applied with the communication. Electromagnetic waves are able to about the state of the electromagnetic field is transfer and is communication from point to point, which are introduced basic antenna propagation sort of these electromagnetic waves. The basic antenna, the study of the antenna of the electromagnetic wave propagation, essentially complete the understanding of the radio communication, the radar, lower and other electronic systems. The figure 123 show the simple radio communication and illustrate for the transmitter electronic device that generates the radio frequency energy. Any travel of the transmission while we'll discover in chapter 3 with to the antenna. The antenna converts the energy of the radio wave. The radio radiate into a space. The antenna is at the speed of light. The radio wave to travel through the atmosphere of the space until they are either reflected or by an object absorbed. And if another antenna is played for them, part of the radio waves, if it absorbs the part of the waves, convert the energy traveled in another transmission line with the receiver. For example, you can see the requirements of the simple communication system: transmitting equipment, transmission line, transmitting antenna, medium, receiving antenna, receiving equipment. I'll show you the transmission station, transmission line, insulator, and antenna transmitter, antenna receiver, insulator, transmission line, station, receiving station, air medium. An antenna conductor set of the conductor is either radiated electronic energy with the space of the collective of the energy from the space of the 124 show with the antenna view A, the drawn without the actual antenna view. B is a cutaway of the antenna view. C with the specified simple diaphragm of the antenna. A is a pictorial insulator. B is the cut away the coaxial input short stubbing the copper tube of the insulator, the top of the rod, tie rod and insulator. Also, figure C shows the simplified diaphragm of the antenna. Alright, components of the electromagnetic wave. The electromagnetic wave consists of the two primary components of the electronic field and a magnetic field. The electric field, the result of the force of the voltage, magnetic field, the result of the flow of the current. Although the electromagnetic field, the radiative, the commonly considered the wave under the certain circumstance of the behavior make them appear to be have some of the particle property of the particles in the greater. However, it is either due to particular electromagnetic radiation space with the horizontal vertical lines, force orientated at the right angle with each other. The lines of the force are made up of the electric field and a magnetic field, which are together make the electromagnetic field of space. The electromagnetic field radiates with the antenna of the electromagnetic field. The field is responsible for the transmission and reception of electromagnetic energy from through the free space of the antenna. However, it is also part of the electric circuit of the transmitter receiver. The equivalent to the circuit containing the inductance capacity resistance. Therefore, the antenna can be expected to display definite voltage current relationship with respect to the given input of the current through the antenna produced the magnetic field. The charge on the antenna produced the electrical field. There are two fields combining the induction field. The two help them gain a better understanding of the antenna theory. They must review some of the basic electrical concepts. We'll review the voltage, electrical field, and current through in a magnetic field. Therefore, the relationship to the propagation of electrical energy. All right, your electric field. Although around every electrical charge object with a force field that can be detected and measured, the force field of the coil with electrical force charge that move in the field. When the object is charged electrically, there is either a greater or smaller concentration of electron, but the normal difference of the potential exhibited between the charged object and the uncharged object of the electrical field is therefore associated with the difference of potential or voltage. The invisible feed or force with the commonly represented with the line with the drawn shown through the path along with the force act with the red line represented with the electrical field or drawn with the direction of the signal of the path of the charge will normally move under the influence of the field. The larger electrical force is shown by the larger concentration of lines of weaker force is indicated by a few lines. When a capacitor is connected to the cross of the source of voltage, such as battery, it is charged with a particular amount depending on the voltage value of the capacity. Because of the electromagnetic force of the battery, the negative charge flow from the lower plate, leaving the upper plate positively discharged. Along with the growth of the charge of the electrical field is also building up. The flux line of the directly positive the negative charge of the right angle to the plate. When the capacitor is fully charged, the relatively capacitor is equal to the voltage source of the opposite of the polarity. The charged capacitor is stored with the energy in the form of the electric field. It can also be said, therefore, an electric field indicate the voltage. Electric field between the plates, capacitor, voltage. If two plates of the capacitor are spread further apart with the electric field must curve to meet with the plate with the right angle. The straight line of the view in A, the figure 126, but between it becomes the arcs in view B. Approximately semicircle of view C, where the plates are a straight line. Instead of the flat plane metal plates are capacitors, two elements that form the metal rods, wires form the basic antenna. Alright, 126 shows the electrical field between the different angles. Figure 127, the two rods replace over the capacitor of the battery replaced with the AC source for the 60 Hz signal. The one positive alteration of the 60 Hz generated electronic field extend the positively charged rod with the negatively and change the rod shown to one negative alteration change the reverse. The previous explanation of electrons moving one plate through the other capacitor shown in figure 125 can also be applied to the rods in figure 127. 127 electric fields between the elements field. Polarity. Polarity of the charged direction of the electric field is reversed to the lighted direction of the periodic frequency of voltage over the electric field will build up at the zero maximum in one direction, the collapse back to zero of the next field will build up the maximum in the opposite of the direction, and then thereby collapse back to zero. The complete reversal will occur during the second single cycle of the source of the voltage of the half-wave diplo antenna. The two separate rod lines illustrated in figure 127. The fundamental element normally either the starting point of the reference into any of the discussion concerning the radiation, electromagnetic energy in the space. If the energy from the AC generated transmitter is supplied with the element of the antenna, the voltage across the antenna lags in the current at 90 degrees of the antenna acts as if it were a capacitor. Alright, your magnetic field. When the current flows through the conductor of the magnetic field itself, the area surrounding the conductor, in fact, with the moving the electrical charge will create a magnetic field. The magnetic field, the region of the space of the magnetic force, can be detected measured for the two other fields involved with the induction field, which exists close with the conductor carrying the current, and the radiation field, which becomes detached with the current carrying the rod travel through space. They're represented with the magnetic field with the line with the force with the illustrated with the energy magnetic line that does not drawn by the rods nor between the high and low potential point of the E lines were discovered earlier. Magnetic lines are created with the flow of the current rather than force of the voltage. The magnetic lines of force, therefore, are drawn in a right angle with the direction of the current flow. Magnetic lines are set up around the two parallel rods shown in figure 128 view A. There's the maximum opposition rod 1 contained with the current flow with the generated with the rod 2 with the condenser of the following with the generator result of the direction of the magnetic field surrounding the rod 1 opposite with the direction of the magnetic field surrounding rod 2. This will cover the cancellation part of all the both of the magnetic field, the result in decrease of the radiation electromagnetic energy view B illustrated the fact that the far end of the rod 1 and 2 is separated with each other while the rods are still connected to regenerate the near end of the more space. Consequently, the less opposition will occur between the magnetic field of the two rods. If you see illustrated the fact that placing the rods in the lines make the current through both rods same direction, therefore the two magnetic fields in the same direction, this maximum electromagnetic radiation in the two space can be obtained. Alright, magnetic fields around an element. Alright, magnetic lines are forces that indicate with the letter H, and they're also called the H line. The direction of the magnetic lines are determined using the left-hand rule with the conductor. Grab the conductor left hand with the thumb and extend the direction of the current flow with your fingers will point. Direction of magnetic line force figure view C with the figure 128. The direction of the current of the upward along with the half of the elements of the conductor line for the magnetic force form. The concentration concentric loop to be perpendicular with the direction of the current flow. The arrowheads of the loop that indicate the direction of the field. The left-hand rule to determine the direction of the magnetic field. Illustrated in figure 129. The left thumb of the left-hand rule is extended with the direction of the current flow with the fingers clenched with the rough circle with the thumb and fingers indicate the direction of the magnetic field. Alright, combined electric and magnetic field. The generator shown of the figure 130 produced the voltage which created the electric field with the current which created the magnetic field. So if the voltage current build up with the maximum value with the one direction, one half cycle, the bin build up maximum value with the other direction during the next half cycle. Both electrical and magnetic fields alternate minimum through maximum value synchronization change the voltage of the current electric and magnetic fields to reach for the maximum intensity of the quarter cycle. Then these fields are induced the field with the sum of the current voltage of the produced electric and magnetic fields of the 90 degrees out of phase and the field of the 90 degrees out of phase. Relationship of the magnetic, the electric lines and the current flow. Chapter 1 Summary.